All right, let's run this same problem in MATLAB. See, there's nothing in the workspace. I'm in the current folder. And over here in command history, you can see I was messing around before I did the screen capture. So we've got all that stuff over there. So the first thing we need to do is define the A matrix. I'm going to use a capital A here and just remind you that MATLAB is case sensitive. So capital A and little a are two different variables. So I'll start with capital A and just type in the matrix. So I have 2, minus 1, minus 1, and minus 1. And I'm going to leave the trailing semicolon off so it'll echo to the screen. There it is. Now, there are two different ways to define the row of a matrix. One of them is you separate the entries by spaces, and the other one is to use commas. They both work. So you can see I replaced the spaces with commas. I get the same matrix back. So let's go ahead and define that B vector now. And that's 2 and minus 4. Now, you can see that the spaces, or the elements along a row, are defined by either a space or a comma. When you want to start a new row, use that semicolon. You can see I used it there too. So let's go ahead and hit return. There it is. So I've got that. Now, I want to append B onto the back of A, onto the right side of A. That's called augmenting. In MATLAB, if you want to put one number next to another one along a row, you can just leave a space. You can also do that with other entities like matrices and vectors. So if I type in this, I'm going to get B as the third column of a third column added to the right side of A. So you can see it right there. And this is this augmented form that I showed earlier. Now this is still just formatting. This means exactly the same thing as the equations I wrote on the board before. In fact, it's easy to recreate those equations from that information. This is just a compact form, and it's standard for matrix algebra. So let's start doing row operations here. And what I'm going to try to get is a matrix that has a 0 down here on the lower part of what's called the lower triangle. The diagonals, which are these two right here, will both be 1, and this one up here will be something else. The process of making that is called Gauss elimination. So we're going to do that. I'm going to start by, on the first equation, I'm going to multiply both sides of the equation by 1/2, or divide by 2. So how do you do row operations in MATLAB? Well, here's how you do it. So A1, now what's that colon thingy there? Okay, that says the first row and all columns. That colon is what we call a wild card. It means use all the numbers available. So in MATLAB, inside the parentheses, the first number is the row and the second number is the column. So pick row 1, all the columns, and that equals row 1, all the columns, divided by A1, 1. So divided by that one right there. Right? And there we go. Now it's showing me in decimal form, even though I typed it in as integers. And since I'm working with this augmented matrix, so I've got A and B, that row operation was performed on both the original A matrix and the B vector. So it's nice and tidy. The next thing I'm going to do, I'm just going to pull that command up again, and I'm going to replace the 1s with 2s. And in doing that, I'm going to make this divide the second row by whatever that first coefficient is in the second row. And you can see there, now I've got 1 and 1 for those coefficients. The last thing I'm going to do is subtract the first row from the second row. Okay, these are row operations, so the new second row equals the old second row minus the first row. And there it is. I've got the 0 in the lower triangle, and I've got a non-zero in the upper triangle. Now right there, that's 1 and 1.5. That's not quite right yet. I need that term right there to be 1. So I'm going to do one last row operation here. And I'm going to divide the second row by that coefficient. So this is Gauss elimination. You can see there's a 0 in the lower triangle, 1 runs along the diagonal and whatever in the upper triangle. So it's easy to see that 1y equals 2. So now I know y equals 2. If I were to substitute that back in, I would find that x also equals 2. We can go one step further here. We can also perform some row operations to make this term equal 0 and this term equal 1, and that's called Gauss-Jordan elimination. Rather than having to back substitute, now you just read the answers off. So let's do something here. Take the first row, and that equals the old first row, plus 1/2 times the second row. Now in doing this, I'm combining two row operations into one command. I'm multiplying the second row by a constant, 1/2, and then I'm adding it to the first row. So I could do that in two separate steps if I wanted. And there we go. So it's now showing as an integer. It's easy to see that y equals 2 and x equals 2. And this is called Gauss-Jordan elimination. So now you know how to solve a basic matrix problem in MATLAB. Wouldn't it be great if there was a command that would just kind of do this? There is. Let's back up here a second. Oops. And let's recreate that original augmented matrix. There is a command called RREF, because this form right here is called reduced row echelon form. And so there's an RREF command you can execute. And there it is. In one command, RREF does Gauss-Jordan elimination for you. So in one command, I got the same matrix there that I had there. So now we've got a couple of tools in our toolbox. The next step is to dig a little deeper into the mechanics of matrix algebra. Now right now I've pretty much just showed you how to do a problem going from row operations into MATLAB. But it's time to start learning about matrix multiplication and matrix inverses, and also some vocabulary. There's a lot of names associated with different kinds of matrices and different operations in matrix algebra. So it's probably time to get those out of the way as well. So we'll do that next time. For now, I hope this helps, and we'll talk to you next time.